All right, folks. Okay, we got a couple things going on today. We're going to work on project 3 and then the final project. I think that puts us in good shape. So our Powerball project. Did anybody win a jackpot when you were testing yours? Like, did you go enough millions to get to it? You don't see the right screen here. Thank you. Is that what you're pointing out? I'm sorry. How about that? Now you can see the big version. Okay. Definitely a pro at this. It's, been 10 plus years and I still have the wrong screen showing, so it's okay. I'm illustrating that people make mistakes. This is on purpose here, definitely. No, but in all seriousness though, like if someone never admits that they're wrong, you don't want to be around them. They're not the right person to be around. It's like everyone will make mistakes, and if you can't admit that, you've got issues. So, okay. So our Powerball lottery ticket, lots of questions on this one, had lots of discussions. Classes are a very different way of thinking of things for us, right? But this allows us to interact with things in more of a natural manner for us because we're used to how this thing works. So I could go to the store and buy a ticket. They would give me a piece of paper. It'd be an instance of my Powerball lottery ticket, right? It has some numbers on it. That's what the ticket knows how to do. That's its attributes. The other thing a ticket can do is I can go and scan it in their scanner and it will say, hey, how much money did I win? Because that has the winning ticket. But our purpose is we tell it what the winning ticket is and it tells me, hey, did you win $0, $4, $7, all the way up to the jackpot, right? That's the thing that you do. That's your verbs, how we interact with that object. That's our functions, our public functions. So we're going to have private attributes and public functions so we can interact with it. So the Powerball lottery ticket should be a single ticket. The idea of having, hey, I want to buy 10,000 of these, well, that happens in my simulator. The simulator says, sure, how many do you want to buy? I'll let you buy 10,000. I don't care. I'll put together a list of 10,000 tickets. But I have 10,000 instances of the Powerball lottery ticket. And then I have an instance of the Powerball lottery ticket we'll just call the winning ticket with some random numbers because it should be drawn randomly. If you want to pick your own numbers, great. So my Powerball lottery ticket, the init method, should handle given some numbers, or if you don't give it numbers, it should generate the random ones. That's the idea here. You can say, hey, I want to do the quick buy, or I want to pick, hey, my lucky numbers are 2, 4, 6, 8, 10, 12, because obviously numbers are lucky. Obviously. I mean, just ask any statistician. They will tell you numbers are lucky. No. So interestingly, though, they did analysis, and like some numbers are drawn more often, which I think was okay because that is the real world, where it's not a perfectly even random distribution because it's the real world, right? We don't actually get a perfectly even distribution of numbers because that just doesn't happen in the real world. And that's okay. We want it to be a little bit different and have a little bit of variance because it's not perfect. And the more we run it here, in the next 100,000 years, if we keep playing Powerball twice a week, we'll get closer and closer and closer and closer to that perfect distribution, right? But we'll never be a perfectly even distribution. That's just how numbers work. And you folks are all pretty good math people at this point, and hopefully that's no surprise. Okay, good. No big surprises there. So let's start a new project here. Call this project 3. All right, so we're going to write our class for Powerball ticket. Now, if we want, we could do it in its own module, right? Its own file. We talked about files and modules. I didn't ask for that. We don't have to do it that way. If you like it that way, that's great. Doesn't need to be there. It would make things a little cleaner sometimes, maybe, but it's okay if we don't. So we just have class for Powerball ticket, right? And then we'll define our init method. So init then could take some numbers here. So any way you want to do this, you want to do it as a single list, if you want to do it as the white numbers list, if you want to do it as a white numbers list and a red number, if you want to do it as 6 different integers, totally up to you. We got lots of different options here. So I'm going to go with the easy route here, and I'm going to say numbers. I'm just going to take a single list. I expect it to be 6 values. So we could check too. If we wanted to do some sanity checking, is good and not required. Like, I didn't ask for it here. We've spent some time looking at what to do if these things are bad, but we could say something like, hey, if the length of numbers does not equal 6, we could raise a value error or something, right? Like this sort of thing. If the numbers have duplicates, raise a value error. If the numbers are out of range, raise a value error. I didn't ask for any of that, right? I'm assuming we know how to do the sanity checking by now. Like we've talked about that, right? So I wasn't saying you had to do it in this project. It's a good thing to do all the time, but we just only have a finite amount of time to cover so much material. And if I say you must always do this thing every single time, you're going to get kind of sick of it pretty quick. But I don't mean to dismiss it. This is good things to do. We should be doing all of this, but we just wanted to focus on let's tackle the important part of the process here, right? So that sort of thing. So otherwise, I can have a self.white, so private white numbers. Then is going to be, I want to take the numbers, and I want to slice it here from that one, from 0 to 5. Right? Not including 5 because this is indexes. So I'll get 0, 1, 2, 3, and 4. I should get the first 5 numbers here. For that, and I'll have a self.red number is numbers index of 5. So it's not really a slice, it's just a single value here. Just give me the 5th index here, which should be the 6th number. Okay. If I raise the value error, remember the code stops, so I can't get to this point here. So at least I've sanity checked I have the right length. I haven't checked if the values are correct. We can do that later. You know, we'll just add a to-do, check for valid range, that sort of thing. Okay, but that's okay. We can get to that stuff later. So that's if I have numbers. If I wasn't given numbers, I need this to be a default argument, right? Because not everyone will give me numbers. If you want a random ticket, you just don't give me numbers. So I can say, hey, this equals none. So this is all really if numbers does not equal none. And really in Python, that's just if numbers, right? Because everything is truthy. Remember this idea that everything is true or false? None is false. So if I say if something, right, it's saying it's not none. So that's why, like, if you say it does not equal none, it gives you that little warning. It says, hey, that's redundant here, comparison with none, right? We don't need to do that. We can just say if numbers, right? That's the thing with if numbers does not equal none. Does that make sense? So just a shortcut there. So if it is none, right, well, then I need to set them separately. I need to take my self-white numbers and I need to assign it to. So now if we import random, so hopefully you guys found this here. Lots of different ways to do this. But random has a really easy option for choice. So choice given a sequence. So I can take a range. I want 1 to 69, so I need a range of 1 to 70. Remember, range will stop at the number, not including the end. So range 1 to 70 will give me the numbers 1 to 69 for my white value bucket. Here, and I want choice. How many of them do I want? I want 5. So random choice, if you looked it up here, that's fine. If you didn't, that's okay. Lots of options for doing this. You can do it one at a time and just compare that we have no duplicates. It's more work than you need to do, or it's okay. We want to be lazy. And if you didn't find it, that's okay. Don't feel bad. Like searching for this sort of thing, you can take you down a big rabbit hole here. But if you just search real quick, like Python, get 5 random numbers, that sort of thing. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund here at the University of Michigan Dearborn College of Engineering and Computer Science. I've had a lot of coffee this morning. I started my day off, which was fantastic. Little coffee shop down the street, made in the Americano. It's like espresso with hot water because it's fancy. Because why not? But it was like a double espresso, and then I had a whole cup of coffee in addition to that, and then I had 2 donuts and a bagel. I'm going to sugar crash real soon, but I'm feeling good for right now. So NumPy can do it. That's probably not what we want to do here. Again, this is like some of that rabbit hole is probably more than we need here. This one gives you a couple different options here for what we would do. Random range, rand range, we don't want any of that. Uniform, no, we don't want any of that. Random below, we don't want any of that. NumPy, we don't want to bother with NumPy. Okay, so that one wasn't helpful, right? Random numbers, choice. This one tells me choice, right? So if you spend a little bit of time, you probably found the random choice here. Takes some values out of here, right? So random number from random range. I think, can't you give choice? Am I doing it wrong? Can't you choose 5? Am I not finding it here? Python, random choice. We can look up some better information about it here. Nope, that's not. Nope, choice doesn't give me, I can't pick 5. What do I want here then? So this is what I get trying to do it from memory. Choose X values. Choices. Returns multiple. Okay, choices then. There we go. So I want choices. Sorry, not choice. Choices. Oh my goodness. Choices. Given 5 values. That ought to do it here. And then red number random.randint. Now this one is just 1 to 26. Now randint is inclusive for some reason, but range is not, which drives me nuts here, but that's okay. Right? Pick a random number 1 to 26. So now I can quickly get 2 different sets of tickets. Either I pick the numbers if I give them the numbers, or I get random numbers if I wanted random numbers, or if I didn't specify numbers, right? And then we can have some sort of way for define like get white numbers. Now, remember when you're returning values, if you return something that is mutable, like a list, someone can go and change it. So if I have my get method, if I just return my self-white numbers here, I can go and change your white numbers, which is a little bit dangerous, right? Especially when we're talking about the lottery. If I give you a way to get your numbers off the ticket, but now you can go and change those numbers, you're going to start winning a lot of money really quickly, right? You're like, oh, hey, get the numbers and then set them to the winning numbers, and hey, now tell me how much I won. So we don't want to give access directly to that. So what we want to do is we want to give them a copy of it here, and we can quickly get a copy with slicing. Remember? So it's safer to give a copy. Again, I'm not going to mark you down at all if you didn't do any of that. That's okay. That's just a good thing to do, right? Because we want to make sure that it's not going to be changed by somebody. So like once you set the numbers, we're taking them, and then they're fixed, right? And I'm even getting a copy here of your values. You can't go change it later because I have a copy. You can't go change your numbers to the winning numbers later and say, look, I won the lottery, right? So it's protecting it. Part of that idea of maintaining the integrity of my class is these aren't changeable. And while they get red number, returns self dot red number. Okay, that was for getting our values out. And then we can do a get winnings. So the idea with get winnings, right, is if you give me the winning ticket. So if you tell me what the winning ticket is, I'm going to compare myself to the winning ticket. So you tell me the winning ticket that won, I'll tell you how much money you won here. So we're going to return some amount of money here, whether that's the jackpot or whatever. So in here now, we need to go and start comparing how many we have that match. So when we look at Powerball, right, and the ways to win, where is it here? This one here. If you match all 5 white and the red, you get the grand prize, you get the jackpot. If you match just the 5 white and not the red, on and on and on. So we have a lot of logic happening here. So I think an easy way to go about this, and again, this is just my approach here, is we'll have a white matches, starts at 0 here, and a red matches. Now, this could be a 0 or a 1, or it could be a true or a false, or any sort of way you want to deal with this. So I like this as a true or false, because it either matches or it doesn't. It's just a yes or no here, where like the white matches is really the number of white matches here. So for the red matches, I can say my self.red number is equal to the winning ticket dot get red number. Right? So this will be a true or false, and I'm going to save that as my red matches, true or false. So take the winning ticket, get their red number, compare it to my self red number. Do those match? Yes or no? Now I know if my red number matches. Okay. Then probably the easiest way to check for white matches here. If you go and search online, there's other things you can do that are probably faster, but this is relatively quick. I can say for number in self.white numbers, if number is in the winning ticket.get white numbers, take my white matches, plus equals 1. Right? Is the number in the list? Remember, because order doesn't matter. We're checking by combination, not by permutation, because all the white numbers come out of the same bucket. There's no duplicates. And I think they're all actually sorted in numerical order. I don't know that for sure, because I've never actually bought a Powerball ticket because I think it's a scam. I was slightly tempted when it got up to 2 billion. I was like, oh, $2, because everyone gets the 1 in 292 million chance, but I figure a 1 in 292 million chance, I'm better off taking the $2 and putting it into Bitcoin, honestly, which is also another scam, but that's okay. It's all right. Everything's a scam eventually. Maybe not everything, but that's okay. I'm a little bit of a nut, and that's okay. I think the whole stock market's a big Ponzi scheme, because have you guys taken an economics class and understand supply and demand? Well, if the federal government incentivizes people through retirement programs and tax incentives to invest in the stock market, where like everyone's 401k basically invests in the stock market by default, they're incentivizing this behavior. They're creating artificial demand for buying stock. So the price goes up because there's more demand. The value of companies doesn't actually change because their stock price has gone up. Right? The company is only worth what they can produce in revenue, I think. I don't have a degree in economics. I don't have a degree in business. I apologize, but I think that works that way, right? You only are worth as much money as you can make. Just because your stock price goes up is because there's more demand for your stock. And in some of this intrinsic value, they think your company will be worth an amount of money long term and that sort of thing, and return on investment. But there's artificial demand in the system, which is nuts. So it's being manipulated. But I still participate because that's the only option in retirement programs. So you have to be part of it. But anyway, I am crazy. I apologize. I'll go off on these random tangents. But I can get the number of white matches. So now it's pretty quick. Then I can just say, hey, if my number of white matches, or if my white matches is equal to 5 and red matches, then I'm going to return the jackpot. And what do we say? We can do 2 billion if we wanted to, right? Let's go nuts. We'll do $2 billion. Okay. Else if my white matches is 5, we're going to return 1 million. Right? Else if my white matches is 4 and red matches, then we're going to return 50,000. Else if. Now, I have 2 different cases here for 100. You could do this either way, perfectly fine, doesn't really matter here. We can say if white matches is equal to 4, or white matches is equal to 3 and red matches. Now, the only thing I warn you here is you want to do order of operations. Like, force that to happen first. Remember, otherwise, your ors happen last, and weird things, or ands, I forget which one happens first. Weird things could happen. So it might be redundant, but this is fine. So this case or this case will return the $100 that you won. Right? And then again, we'll go down to $7 if you match 3 or 2 in red. And then for $4, it's you just match the red one. We don't care if you matched 1 white or not. Right? So then I can just say, oh, if my red matches, return 4. And if none of that happened, you could just have an else, but that's kind of redundant here. We can just return 0. Right? Because these are all if-else ifs. One and only one of these will run. If none of them ran, we'll get to this one anyway. It doesn't really have to be an else. If you like the else here, that's perfectly fine. There's nothing wrong with it here, but it's redundant at that point here. So, sure. Doesn't matter one way or the other. You did some extra typing. And that's how I determine how much I won. So, given the winning ticket, find how many white matches there are, see if the red one matches, and then just go down the list. Now, the order in which you do this is important, right? I want to check for the jackpot first, because if I don't do it in the right order, if I check my red matches first, then I'm going to give you the wrong amount of money and you're going to be upset with me. The state will be happy because they're making lots of money off of it. Apparently, the real winner here is the company that prints lottery tickets. So not necessarily for Powerball, but like the scratch-off tickets, they make a lot of money selling those things because they're like kind of expensive to make and they charge the state lots of money. Powerball's not so expensive as a system, but the scratch-off ones seem to be very popular for people. And I get it. Those are kind of fun. Like, you know, take your coin and scratch the money off and things. So those are fun to give away at Christmas time. Like, it entertains people and it's cheap. It's like a $1 gift, but like you're gifting them hope, which is also really sad. Like, I worked with a lady when I worked at the help desk, and you know, bless her heart, she was just going to work at the help desk for the rest of her career because that was fine. Like, it was not a career for her. This was a job that paid the bills, and that's okay. There's nothing wrong with having a job to pay the bills and then having a life. Like, you don't need to live your career out. Some people like that. Some people find fulfillment in that sort of thing. That's great for you too. Like, everyone can have a different thing here. But her quote retirement plan was playing the lottery, and like $20 to $50 a week she'd spend on the lottery. I'm like, lady. And like one time we did the math because like I was a young kid. I was like, I can change your mind and change the world. Like, she just ignored me. I was like, look, you're spending, you know, $50 a week across 50 weeks. $2,500 or $2,500 a year. If you just stop doing that for 10 years now, because like she was going to retire in 20 years back then, I was like, you would have saved $25,000 or $50,000 in 20 years. And she's like, wow, that's a lot of money. Like, yes, yes, it is. Yeah, exactly. Like, well, what if I win? Oh, and you know, one time I won $100. Yeah, sure, but you spent 50 grand over 20 years, lady. Like, can't. You know, but apparently people. And it's true. People are bad at long-term decision making. Just in general, humans are bad at that sort of thing because we're really good at short-term, quick satisfaction gain sort of things. Our brains are wired for that sort of thing. Like, hey, I want something now. I want that quick satisfaction now. And that's tough. It's hard to teach people to think long-term and that sort of critical thinking. That's one reason I actually really like. They're pushing now for chess programs in inner-city schools, where for lots of other reasons here, but it tends to be more of an issue there for long-term thinking in inner city schools. I don't even pretend to understand all the reasons, but if you teach chess, you can teach long-term strategic thinking, planning skills in a game format. Well, if I make this move, what happens? What's my next move? What am I planning? What's my goal here? You can teach that sort of skill, which translates somewhat into life skills strategic planning sort of things. Like, hey, in my life, if I make this choice and make this choice and do this thing and do this and whatnot, which is really interesting. Anyway, so here's our lottery. So here's the Powerball ticket class. It represents a single instance of a ticket. Right? You can have its attributes. It has red numbers and white numbers, or red number and white numbers. It can tell you how much money it won if you tell it what the winning numbers are. Give it the winning ticket here, and then you can get the values back out. That's about it. That's all Powerball ticket does. Then our simulator now, the rest of our code, everything else we're used to writing, is going to track my net loss. You know, how much I spent, how much I won, what the net loss is. Ask me, do I want to pick the numbers? Make sure I pick random or valid numbers in the range. And then, or just get random tickets, do that sort of thing here. So the rest of that here lets me play as much as we want. Pick tickets, buy random tickets, pick the random numbers, make the tickets, ask how many, generate the winning ticket, display the winning ticket, compare the numbers or tickets, display the money that they won, and keep on repeating. So sort of like while, I don't know, play again equals a Y, sure, and while play again equals a Y. Sure, we'll keep on doing this here. So we'll probably have a total spent is 0, a total won is 0. Now, you don't need to track the net loss because that's just arithmetic, right? It's your spent minus your won is your net loss. No, I'm sorry, your won minus, no, spent, oh my goodness. Yeah, spent minus the won. Because if you have actually won a lot of money, you won't have a net loss. It would be negative, and a negative loss is actually a gain, but like you should always be losing money essentially because it's the lottery. So maybe that gets a little confusing, but that's okay. So we'll ask them, hey, do you want to buy tickets or do you want to get random tickets? So we can have a I don't know, ticket type maybe is equal to an input of we want to pick numbers or get random tickets. And then I don't know, what do we want to ask them to enter here? Like, I don't know, P or R, I don't know, like totally up to you, whatever choice you want to have for your input here. So if my ticket type is P for pick, and then probably again lowercase this sort of thing because who knows what we get here. Let me see if I can shrink that a little bit here. Got lower, sure. If the ticket type is P, sorry, double equal sign here, then we want to get some numbers out here. So now we need to go ask them for some values. So we want to set up the list of white numbers. So my white numbers is going to be, actually this could probably just be numbers here, right, at this point. So numbers is going to be a list here, and then we want to get 5 numbers. So for number in range 5, we'll ask them to enter a number. So our number will equal an int of an input, enter a number 1 to 69. Okay, and then while it's invalid, we want to keep on asking them for that number. Right, so maybe we set number equals 0, and while number is less than or equal to 0, or number is greater than or equal to 70, or number is in numbers. Right? If it's a repeat, that's also invalid. If it's more than 70, it's invalid. If it's less than 0, it's invalid. If any one of these are true, it is invalid here, and we should keep on asking. Right? Sure. It might be nice to tell them some sort of prompt like that was invalid, try again, but that, you know, whatever we want to do here, that's okay. Or how about enter number 1 to 69 for number, and then we can append in here, how about that? The length of numbers plus 1, because most people don't understand 0 as the starting number, so the length of numbers plus 1 will be 1 the first time, and then 2, and then 3, like enter number 1 to 69 for number 1, number 2, number 3, number 4, number 5. And then if it repeats, we don't even need to give them an error message. We'll say, hey, enter number for number 3, enter number for number 3, enter number for number 3, if that makes sense. Again, just nice to have some sort of checking here. Once it's valid, we'll take my numbers and we'll append the number to it. And we'll keep on going 5 times. Right? Then we need to get the red number. So now my, I don't know, number equals 0 or something, we'll just reset it here. And while number is less than or equal to 0, or number is greater than or equal to 27, right? Because 26, once 1 to 26 is valid now, my number can equal number 1 to 26 for the Powerball. Right, that's the red number, is the Powerball number. Right, and if it's invalid, we'll keep on going. As soon as it's valid, the loop will stop running. It's no longer true, right? And we can take my numbers, we can append number. Right, this whole thing to make a ticket then, so then my ticket, or player ticket, I don't know, or ticket equals Powerball ticket given the numbers. Right, we can call that numbers init method, our constructor here, given the numbers. So we'll tell it, here's my numbers I picked. We made sure they're valid. Again, it's good for the class to do that too, because the class wants to maintain its integrity. Our whole check goes out the window here if we have duplicates. If I allow you to have a ticket 1111111, and there's a single 1 in the winning ticket, I'm going to think now you have 5 white matches, and I'm going to give you way more money than you should have gotten because your ticket's bad. Again, we're not checking for that. That's okay. Don't worry about it. Right? It's another, it's a to-do here. That's fine. We can get to it later. Not that important right now. Is that okay? We just kind of wave that off. I'm assuming that's not the hard part of this assignment. Okay. Then, now that I have a ticket, right, I'm good to go. So my else here then is going to be the random, right? So else, or really just if it wasn't pick here, I'm assuming it's R for random. That's fine. We'll ask them how many tickets do you want to buy, right? So number of tickets will be an int of an input of how many random tickets do you want, right? We can do that sort of thing. Now, I do need a winning ticket as well. So I can actually start with a winning ticket. Winning ticket is equal to a Powerball ticket. And if I don't give it the numbers, I get the random numbers here, right? So I make my ticket, and then we can print out the winning ticket and say, hey, this is the winning ticket. Winning ticket is, how about we format this here? Here's the winning ticket, but that's not going to print nice, right? Because we don't have that string override. We want this string override to represent a ticket as a string. So that's okay. That's the other thing we missed here in Powerball ticket. So we need a way to represent ourselves as a string. So if we define string for self, we can return a what do we want here? We want a string of space dot join my self white numbers. Right, that'll be the white numbers here, right? And we want to append in space Powerball, and then plus the self.red number. Right, I think that'll give me a nice string representation. So space separated white numbers with the Powerball listed. If you didn't include the word Powerball, that's okay. It doesn't really matter. It's just, it will indicate that nicely for us here. Okay, so then I can just print the winning ticket, and when you call print, if there's a string method, it will try and turn it into a string. We get that string version here. And then we can tell you how much money you won. So then you won, a formatted string here of my ticket. So ticket.get winnings, winnings, given the winning ticket. And then maybe we can put in the $sign here, right? And then take my total 1 plus equals the get winnings here again, right? Sure. And then my total spent was $2. Now that's something Powerball ticket might know. We didn't really get into static or class level attributes. You don't have to define everything as a self dot. We'll get more into this next semester. But like if you can have something like a ticket cost or something too, so it belongs to Powerball ticket here. So my cost, I can say Powerball ticket dot ticket cost. Don't worry if that doesn't make a lot of sense, but that's a static class level attribute here. We can talk more about that next time here. That's the cost of the ticket. And then we could print out total won, total loss at the end, but we're going to do that no matter what here. Right? And so our number of tickets then, and I can say for ticket in range number of tickets here, I can make a ticket. Right? So my ticket is going to equal a Powerball ticket, which is a random ticket, and then we'll print the winning ticket. So probably just one time here. Right? Here's the winning ticket, and then we'll print you won. Getting the winnings from the winning ticket, right? Add this in here and do that every time for as many random tickets as we want, right? Maybe we want to print the ticket as well. I don't know. Maybe we do that. So we say ticket wins, right? So your numbers wins this much, sure. I mean, that might be a little bit of a prettier output here for the random tickets, because you know what your numbers were in this version here. I probably don't need to tell you again, but for my random tickets, I'll say, hey, here's the random values. This is how much money you won. Sure, why not? We can do that. That's it. And then when we're done, now we'll print your total spent. Here is your total spent, right? So the format string, total spent. Your total won is, we should probably add some dollar signs because dollar signs are pretty, right? Total won. And then your net loss is going to be your total spent minus the total won here, right? And then we ask if you want to play again. Play again. It's equal to an input of you want to play Powerball again, y/no and lowercase that, and then that whole loop just keeps running if it's a yes. Right? We just keep adding to total spent to total won over and over and over. I think that's about it. Let's see if it runs. I'm going to cross my fingers. Oh goodness. Keyword argument. Okay, so I was wrong with choices. My mistake. So I did not Google that well enough here. So choice is k equals 5. So pick 5 k choices. Thought that was just that's okay. I'll try that. Oh goodness, random takes no arguments to random randint. There we go. Random.Randint. Okay. Do you want to pick our tickets or pick random ones? Pick our numbers or get random tickets? What do you guys want to do? Okay, pick first. All right, enter number 1 to 69, number 1. What are our lucky numbers? How about prime numbers? Prime numbers are lucky, right? So 2, 3, 5, 7, 11, and then 13. Oh, uh-oh. Sequence item 0, expected string instance int found. Oh goodness, what do we do? So white numbers is a bunch of integers, not a bunch of strings. We can't join it directly. We have to do this silly string interpolation thing. So we can say for string of number for number in self numbers, right? This sort of like backwards for loop. We looked at these briefly, right? List interpolations. That was our term for it. Thank you for shaking your head because I get confused sometimes. So again, just like a for loop, but we did it backwards. We'll take the string version of that number. So hopefully that one works better for us now. Are you okay with prime numbers, or do you think other numbers are luckier? I should have. I was going to ask you, and then I just came up with prime. I'm sorry. They're fine. Okay, 2, 3, 5, 7, 11, 13. Oh goodness. Can concatenate string, not int to string. Yes. Okay. The string version of self-read numbers. So this works nice when we print here, but when we're doing strings, we have to concatenate strings here because Python gets confused. We're getting there. We are getting there. Let's try one more time. Pick numbers. Pick the numbers. 2, 3, 5, 7, 11, 13. So the winning ticket was 48, 22, 64, 29, 30, Powerball 19. We won $0. Total spent 2. Total won 0. Net loss. Oh, our net loss is not as pretty here. We forgot our dollar sign. Okay. You want to play again? Yes, keep playing here. Pick tickets or pick numbers or random? Random. How many tickets do you want to buy? 5? All right, so we bought 5 tickets. So the winning ticket was this one here. We bought this one wins 0, this one wins 0, this one wins 0, this one wins 0, this one wins 0. Oh goodness, we didn't have any matches. So the red ball is easiest to match here to find a winner because you only need to match 1. Otherwise you have to match at least 2 white numbers, and that's kind of hard to see. We could also sort this if we wanted to make it a little easier for us to see with our white numbers. So like afterwards we could sort our white numbers. That might be nice. So say self.whitenumbers.sort. Right, that will sort in place a list. We don't have to reassign it, right? Or we could do the sorted and reassign. Either way is fine. All right, so let's stop and rerun it here. Let's try, I guess let's do like 100 here. See if we can get some winning money here. Oh, we won $15. Okay, so we found a winner. So let's see where we won here. Here's $7. How do we get to 15? Oh, 7, 4, and 4. Okay, So this one's $7. So Powerball was 21. We must have matched that and a white, you think? What was the winning number? Yeah, Powerball was 21, and we had 3, 35, 40, 65, and 66. 3. So we matched 3 and 21. We won $7, right? And then two $4 winners somewhere in here. Where is it here? Here's a $4 winner, matched Powerball. Another $4 winner. Where is it here? Here it is, matched the Powerball. Okay? So you might be thinking, how do we make sure we did this right? Shouldn't I test my code? I'm glad you mentioned that. That's good thinking, folks. Good thinking. So the easy way to test this here, right? Did we talk about unit tests when we wrote classes? When we wrote unit tests? We didn't. We'll save that for next semester. But if I wanted to make sure this works here, instead of doing my little simulator here, we could fake it, right? We could say, hey, I want a ticket here. Ticket 1 is a Powerball ticket, given some numbers, right? Given 1, 2, 3, 4, 5, and 6. And then ticket 2 is another Powerball ticket, given some numbers. And now I'm going to do it in reverse order here, just to make sure my checking works nicely here. And then we can print ticket 2 to get winnings, given ticket 1. This should be a jackpot, right? Because the first 5 match, and then the 6th matches. Should give me a jackpot. Look at that. We got our jackpot back out. Okay, so if we don't match the the Powerball number here, we should get the $1 million prize, right? We can do the same thing again. So give that a run. Now we get the $1 million prize. Again, the formatting is really ugly. That's okay. We can clean it up later. Don't worry too much about it here. Or we could go Google it, right? So Python string format for digit separator, colon, comma, should add my 1,000 separator, right? Colon, comma. So print winnings here, given a formatted string of ticket get winnings, colon, comma, should give me the digit separator, right? Don't bother Googling or memorizing that, just go Google it, right? I think that was one of the quiz questions. I think I recently graded that one for you folks. There we go, now we get our digit separator. It's a little nicer to see. Okay? So we would go through and give it each different combination to make sure it worked for me, right? Hopefully you didn't just do 100 million random tickets and see what you got here. That's an option here though, right? We can do that sort of thing. I want, right? Nope, what's the, nope, not that one. I just want to comment that out. Code, comment with line comment. Oh, just control slash, there we go. So I'll leave that there. Another thing that might be nice here is we could print this if it wins money, right? If my ticket get winnings, then I want to print it out, right? Again, this is Python being truthy. If it's 0, 0 is false. Nothing happens. So I could say if it's greater than 0, but it just works by default here. So you'll see this a lot when you read people's Python code. They depend on this truthy behavior, where if a number is 0, it's false. If it's not 0, it's true. So now when I run this here, I'm only going to get the tickets that win me money here. So random tickets, and I buy, say, 10,000 tickets. Here, I'm only going to get the winning ones, right, to save me having to sort through a bunch of those other ones. Right, those are all $4 tickets. That's a bunch of $4 tickets, bunch of $7 tickets. Don't really. Okay, there's a $100 winner. Wait, Powerball's 21 again? Did that really work out where it's 21? So look at that. So we spent $20,000 on Powerball this week trying to hit the jackpot here, and we won $1,943. We're only $18,000 in the hole. Not a bad week overall, right? Sure. Then again, you could do this sort of thing. So maybe we'd say, hey, if get winnings is greater than 10 or something, right? To only get the bigger winning numbers here. And let's do 100,000 tickets here. Okay, so we won 20,000 now for spending 200,000. So we only lost 90%. Not a bad average, right? So now we'll see, here's my $100 winners. Nothing more than a $100 winner here. Let's run it again. Do random tickets. We'll do 100,000. Still only $100 winners here. Let's try it again. Let's go, actually, let me stop this. Let's do more than 100. Let's skip the $100 winners. Let's only go with the bigger prizes here. So tickets, let's do 1,000,000 tickets. So with 1,000,000 tickets, well, there's a $50,000 winner. Okay, a couple $50,000 winners. We got a jackpot. Look at that. We won some money, although now we're going to have to pay taxes on it and all sorts of things. So we spent $200 million to win $2 billion that we're going to lose 50% of to taxes, and you only get 50% of that on top of that. So maybe we got ahead here because we got lucky, right? This was a 1 in 292 million chance, and we only did 100. What do we say? 1 million? That was actually pretty lucky, right? That was like 1 in 292 chance to win there. I should go out and buy a lotto ticket. I'm really lucky today. But that sort of thing. So it can happen, and that's fine. It can happen, yes. Statistically, it's really rare, and that's the reason it's a lottery, that sort of thing. Okay, questions, thoughts, concerns about Powerball? Again, using classes here is a very different way for us to think about solving problems, but hopefully you can see as we kind of talk through it the benefit of I treat Powerball ticket as a single ticket, as an instance of this noun, right, of a ticket, and each one has its own set of attributes, and it just sort of works here. Does that make sense? How'd you guys do? Yeah, good, bad, just as okay. All right, okay, not too bad. So let's talk about the final project. We go and add final project here. Yeah, there we go, final project. So this is due, when is our final date? Was it the 12th or the 14th? I can go look. 14th at 11 or 11:30, right? I think we're 11:30. Okay, so 30 points total for the 30% of your overall grade here. That can work out pretty well here, I think. To make a new repository. So again, I would encourage you to work in pairs on this. I'm not going to require it because that's okay. Like not everyone likes that, but it's I promise you it's really good. And you get to pick your partner. So if they suck, fire them. That's okay. Like I don't want to work with you anymore. Just be honest. Like you need to have clear expectations and clear boundaries. You said you're going to do this. You didn't get this done. I'm done working with you. That's perfectly okay, right? That's normal. It's okay. It's not like the industry where you get hired onto a team and they're like, good news, this is your team, where you don't get to pick who you work with. That's a little rougher sometimes, depending on who you're working with. But hopefully you work with good people. And again, when we don't expect as much from fresh graduates, right? You're more of a junior level developer, software engineer, data scientist, whatever. As you get into the industry, we know that you're fresh out of school. So you probably will be learning from senior level people and that sort of thing. And it's usually a good thing here. But sometimes it can be rough, being forced to work with certain people, and that's just life sometimes. But we have the option to just not. Here, you gotta do it yourself. I just ask you do communicate clearly with people. Like, don't just be like, hey, I'm done working with you like the day before it's due, right? Like, but like if you to agree to get something done by a certain deadline and it's not done, feel free to fire them. Right? That's okay. Like you don't have to be held up too far. So we'll have a check-in the last week of class. I will check in with you. We'll meet during our lab time during that last week, and I'll be checking with all the groups here and saying, are you at least this far along, and that sort of thing, to make sure we're making some progress. So we make this repository. So if you work with partners, I can add you to one person's repository, so you both have access to it. So you can both make commits and pull and work on it. So the thing that makes that easier is if when you go start here, hit this little fetch button. It'll make sure that you get the latest and greatest version that they might have changed first. Because if you both change a file and try and commit, it can get a little ugly. It's always fixable, but it can get a little ugly. And sometimes I just have to hop in and help you with a screen share, but that's okay. Project 3, don't want any of this Lab 8 stuff. Don't want any of that, actually. Push, we'll get rid of these. Yeah, I thought I got rid of that already. That's weird. Okay. So here's our repository. We're going to submit the URL to your repository. Transitory, working in pairs, both partners need to submit. So if you both don't submit, D2L or Canvas doesn't flag it for grading, and then it'll be really sad if you don't get a score. So you can just both turn in the same URL, which is fine. Like, I'll figure that out, but you both need to turn something in, otherwise Canvas gets confused. Because I can set it as a group assignment, but then like if you're not in a group, it gets really weird and that sort of thing. So this is usually just a little easier here. All right, give me just one sec here. I'm going to go copy paste here for fun from this project, because we're doing the same thing because it is awesome. We're going to make a blackjack simulator. So blackjack is a card game that is played usually at casinos. And the idea is you play against what's known as the dealer. So you both get 2 cards here, and the cards have face values and suits. We don't care about the suits in blackjack. The face values are what we care about. So you get a number of points based on the face value. So 2 is 2 points, 3 is 3 points, on and on and on. 10 is 10, and then Jack, Ace, and King are also worth 10 points each. And then Ace is either 11 or 1. So if you're going over the goal, it becomes worth 1 to save you some time and keep you from failing. So the goal, other people call this 21. The goal is to get to 21 or less and beat the dealer. So the advantage is always to the dealer because they go last. So when there's played, they play against players, but the players all play against the dealer, not each other. Or like poker, all the players play against each other. There is no dealer. There's a dealer, but the dealer doesn't play. So in this case, everybody gets 2 cards. The dealer gets 2, but only one of them is face up. So you only see one of the dealer's 2 cards here. And then what happens is you can either hit, which means you take another card, or you stand, you stop taking cards. So the goal is to end up not losing. So you lose if you go over 21, or you lose if the dealer has a higher total than you. You lose. So multiple ways to lose here. So what happens is that the dealer has a face-up card, and you have a hand total. So many points here. Based on what your total points is, you should either hit or stand. This is the mathematical approach here. This is proven out with math. We're not going to do math. We're going to just play 100,000 hands and see if we get the results that essentially equal this here, which is fun. So we're going to simulate playing a bunch of games here to build a result list of saying, okay, when my hand total was 18, and I stood, how often did I win? How often did I lose? How often did I draw? When my hand total was 18 and I hit, how often did I win? How often did I lose? How often did I draw? If you're at 18 and you hit, you're going to lose a whole lot. But that's okay. We just want to do this a bunch of times and build that result list to say, hey, this is what happened. So we're kind of building a model, and then we're going to run the model a bunch of times and get our results back out. So the goal for blackjack is, first we're going to write our blackjack classes. How do we represent the game of blackjack using classes? What is a hand? How do I know if a hand wins? What's the dealer? Where do I get my cards from? This idea. In blackjack, they typically use something known as a shoe, which is just a bunch of decks shuffled together. There's 52 cards in each deck because there's 13 face values in each suit. There's 4 suits. I'm sorry if you all know this. Some people have never played blackjack before, or like have opened a deck of cards, which really confuses me because I did that a lot as a kid, but I'm an old man now, so that's okay. So usually it's about 6 decks of cards or more shuffled together, and then you take off of that big stack here. And then when there's about less than 100 or so, all 6 get shuffled together again, and you start back over. So that way you're not like taking a single deck of cards, you're using multiple decks of cards. And the reason is it's easy to know which cards are still in play or haven't been played yet if there's only one deck of cards. My brother's really good at this. He's got a really good memory for counting cards and that sort of thing. Playing euchre against him is just nonsense because he knows what's in my hand. And it just drives me nuts. Which is fine when he's my partner, but if I'm playing against him, I just like lose all the time because he's like, okay, I know you have these 3 cards in your hand. I'm like, how do you know that? He's like, well, you played this, you played that, and they had this, and it's okay. That's what it is. So multiple decks of cards make that shoe. And then we have a hand, the dealer has a hand, we go first, then the dealer goes second. So if you bust, if you go over 21, you immediately lose, regardless of what happens to the dealer. If you stay at 12 and the dealer busts, you win. If you stay at 12 and the dealer stops at 17, 18, 19, 20, or 21, you lose. So the catch here is the dealer has a specific rule. They will always take cards. Why is my link not working? Oh, it is. It was already on the page. The dealer will continue to play until they get to 17 or higher. So you can stop at any point. You can stop with a total of 4. No one makes you take cards. So in our simulation, when we play 100,000 hands, we'll say, okay, this was my starting total. I had a total of 4 points in my hand. Half the time I stood, half the time I hit. When I hit, how often did I win? How often did I lose? How often did I draw? When I stood, how often did I win? How often did I lose? How often did I draw? So we're just going to get the results out of that to see which is the better option. Generally, which one wins the most, right, is generally the better option here. So we'll build out a results table based on what our starting value was here and what the dealer's face-up card was. Now, this part's not even all that important for us to track. It's useful to know because it does change these. So having a 17, or I'm sorry, like having a 15 is very different if the dealer has 2, 3, 4, 5, or 6 versus 7, 8, 9, or 10 or ace, because the jacks, queens, and kings are all worth 10. That means 4 out of 13 cards, every 13 cards is worth 10 points. So that's the bulk of the cards, not the majority, but a lot of the cards are worth 10 points each. So if they have a 7 face up, there's a pretty good chance, right, 4 out of 13 chance that they have a 10 that you're not seeing. Or if they have an 8 showing, so like they will get to 17, 18, 19, or 20 and stop and not bust. So you stopping at 15 is not a very good strategy if they likely have a 17, 18, 19, 20 already, right? So for each of our face-up totals and for each of the dealer's face-up cards, we're going to figure out what was good for us. So we need some way to store all of that information here and say, okay, this is the starting result. When I hit, I got this. When I stood, I got this. And we just keep on adding to it 100,000 times. Eventually, we'll get all of these combinations here, right? There's only 1, 2, 3, 4, 5, 6, 10, right? That's 10. There's 10 different face-up card dealers cards. And then our totals, there's going to be a bunch of different ones because we can go all the way down to 2 if we have, I guess it's really, the smallest would be 3. Not even 3. I guess the smallest is 4, right? Because 2 2s is a 4. If we have an ace in there, it's going to be worth 11. So you'll never have less than 4 as your starting hand. But you'll have 4, we'll have 5, we'll have 6, we'll have 7, all the way up to a 21 starting hand total. At 21, if you hit, you are probably going to lose every time. It's possible that you don't if you get another ace. Or I guess your ace would turn into something else. So you're not automatically going to lose, I guess. But you will win much less often by taking a card than you will just staying. Staying at 21 is the best option, right? Because that's the best total. So the worst that can happen when you're at 21 is you tie with the dealer, and if you draw, you just don't lose any money. You get your bet back. Okay? So the first part is just building the classes out so we can play the game. Part 2 then is actually making a game you can play using user input. Asking the user, okay, here's the dealer's face-up card, here's your 2 cards. Do you want to hit or stand? 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 You busted, you lose. On and on and on. Just assume every hand is worth $1, and we're going to track their wins and losses. So in blackjack, it's possible to get close to winning odds. You still have losing odds, but it's the best game to play against the house in terms of odds at a casino typically. You'll have the best chance of winning money, which is still a chance of, is more likely to lose money, but you have a better chance of winning at blackjack. Then once we've done that, like this is sort of testing, does your part 1 work here? Can I play the game? Does it work? Do they take cards up to 17 and stop? What does the dealer bust if I win? Do I win if the dealer busts? Does the dealer win if I bust? That sort of thing. Playing it, trying it out. That's sort of the fun one. Once that works, then we're going to stop asking the user, and we're just going to do this 100,000 times and say, okay, here's my starting hand value. Half the time I'll pick a random number 1 or 2. On a 1 I hit, on a 2 I stand. Sure. What happened when I hit and when I stood? So we're going to build out a big list of results here that we're storing. For every time this was my starting value and this was the dealer face-up card, this is what happened when I stood, this is what happened when I hit. And I get win, loss, and draw. So we have a bunch of information we're going to be storing here in some sort of big table. However you want to store that data, right? Whether it's lists, whether it's classes, that sort of thing. I'm quite fond of classes because I think that works out really nice. Like the class that might represent like your statistics could have your hand total and the dealer face-up card, right? And then your total wins, total losses, total draws, that sort of thing. Or like hit wins, hit losses, hit draws, stand wins, stand losses, stand draws. We could have all those be as attributes in a class if you wanted and store them in a place. It's got lots of choices here, lots of different ways to store the data. There's not a wrong way to do it here. Right? Any way we store the data is going to work, but some things might be easier for us conceptually. Right? That's why classes are nice. So like, if you think of like results as the thing we're storing, right? The attributes of results would be the total wins, total losses, total draws for each hit and stand, and then we could also include my hand totals, my starting hand totals. We could include the dealer, cards, and have all of that. So we'll get a lot of data at the end printing it out. So in terms of the presentations, you're going to show that you can play the game, and then you're going to show what happens when you run your simulator. And then I might ask some questions about your code. You can show me this or that, and then it'll be done. So 5 minutes or so for presentations as usual, maybe up to 10 if you're really excited and want to talk about your code a lot, which is fine. Some people like to talk a lot. That's okay. We're not a huge class, so if everyone has to take 10 minutes, that's okay. But we should be 5 minutes or less for most people, and we'll get out the door on our final exam day, where you just present your project. So we've got about a month to get this done and out the door. Right? We want to start doing piecemeal, working on the classes first, designing it here, taking time to think about how this should work, what our classes will look like, what the code will look like, is going to be worth your time. If you just start writing code, it's going to be a lot harder to actually make it workable using the game here. And that's sort of the idea. When we build those models, we have pictures of things. We understand, okay, these are the attributes. These are the ways we interact with it. This is what's going to happen in our code. Here's the step, here's the step, here's the step, here's the step, here's the step. We can get that down in English and figure out what has to happen. Then we can translate it to code. Okay. It's not too bad. It feels like a lot. There's a lot to it, but it's not too bad to do. It works out pretty well. So like, you might have a class that just represents a card. What's the face and what's the suit? You might have a class that represents a deck of cards. Sure. You might have one that represents a shoe. Not everything that is a noun has to be a class, but it could be. Right? That's totally up to you. That's part of this. The art of how we design solutions here is what makes sense for it to be a class or not. So have as many as you want, have as few as you want. It's okay, but you have to have like at least a class here for the blackjack game, because if you don't, there's no chance that you can play the game and simulate the game. We need like both of these goals in mind for the game to work, where I can have a method that says, hey, the player wants to hit, the player wants to take a card. There needs to be a way to do that in our program so that when I'm asking the user, do you want to hit or stay, I can make it hit or stay. Or if I'm simulating it, I can pick a random number and say, okay, if it's a 1, they hit. If it's a 2, they stay. The same function has to run regardless of the user told me to run it or my simulator told me to run it. We need a way to interact with our hand that takes another card or not in the game, right? And then we need a way for the dealer to have their turn, right, where they get to 17 or higher and stop or they bust. And then if the player didn't bust, they win, right? That sort of thing. We need a way to get those results out here. Does that make sense? There's a lot to it. We've got some time. We're off next week for Thanksgiving. The whole week we're off. There's no meetings, no class meetings. Don't come. You'll be lonely here on campus. Although the campus is open, partly. Some of the buildings are open. They've got like weird special hours. The ELB is open most of the time. I don't remember what the lab hours were. I'd have to look and see. I don't know if you all have laptops. I don't think you come to the lab, but just use the computers. But parts of the campus are open for sure. Questions, thoughts, concerns? Yeah.
For our table, can we just make that and put it like a PowerPoint or something?
But it just like prints out to the console.
Oh, okay.
Yeah, you should just print it out. Like, say, here was my hand total. Here's the dealer face up. Here's my wins, losses, draws for hits. Here's my win, losses, draws for stands. And just you print a bunch of lines. So you could then go like copy paste it into some sort of Excel document and make graphs and make pictures and then do all sorts of fancy pretty things. But like when we get to plotting, we could actually plot our results here and get a nice little line graph and show you, hey, here's your win count increases when you do this, it decreases when you do this, and lots of ways to show that data. But for now, we're just dumping it essentially. Yep. Okay, so this is the sort of a data science project. It's a primer on how we can solve problems using computers, where we build a model and then we just try the model. Let's take a real world thing, make some code that simulates it, and just do it a bunch of times, because not everything is solvable with math. Like blackjack is. We could go ask your stats prof to how do I figure out the odds of winning blackjack, and they could tell you a mathematical formula, right? It's doable. But not everything in the real world you can find a mathematical formula for. So we need to make a way to model it and say, okay, let's just do it a bunch of times and see what happens. That's our best bet here. So someone had a really cool project. I think it might have been the number file folks or somebody. They took Monopoly and they said, what is the most common space to land on in Monopoly? And someone did the mathematical approach because number file is good at math. And then someone wrote a Python program. It's like, I'll just simulate the board and see what happens and track the results. Right. So both ways work. I could not have done the mathematical approach. I just not that good at math for how he did that. Because like you have to account for the chance cards that take you to certain spaces and like the chance of landing on a chance card and then getting one of those chance cards that takes you there. And then it was a lot. It was a lot. But like he wrote it all down on his, butcher block piece of paper with a Sharpie. Like, wow, that's really cool. But do you guys watch number file videos? They're really fun. Really fun. Okay. They have one on Enigma. We'll do that next semester. Enigma's really fun. It was the code machine from World War II. It's a really cool machine. All right. So we're all set then. I'll be around next week. I'm going to be working on grading stuff. I know I'm behind. I'm sorry. It's getting sick after I was gone was not, I should have known better that I just would have gotten sick. It's germs, but that was not the plan. So I was supposed to be caught up then, but working on getting caught up this week, and then all of next week we're off. So I'll have more time to get some grades done for next week. We should be able to go from there. Okay. All right. Awesome. If you got anything else, let me know. I'm happy to meet with you.